Hello viewers, welcome to Famous Julius Academy. On today's video, we shall be looking at balancing of chemical equations using algebraic method. So now we have several methods for getting the balancing of chemical equations, but we are going to be precise on using the algebraic method. We have a method of Gaussian, which is try and error, but that method sometimes does not work because you have to do try and error, and sometimes at the end of the day, you will not get your answer. So it's better you master using the algebraic method. Or if the equation, for example, is the equation that you can easily balance, you can go ahead and do that using the trial and error. But there are some certain equations that you cannot easily balance just by guessing. So that's why it's very important for us to go with the algebraic method. Now let's see how we can balance a chemical equation using the algebraic method. So first of all, we are going to write the equation in the board here, and I'm going to write the combustion of propane. Propane is an hydrocarbon with a molecular formula of C3H8. So when propane undergoes combustion, that means propane reacts with oxygen. It's going to produce two products, which is carbon dioxide and liberates H2O as well. So this is the gaseous state. So this water here is in form of vapor, and this is the gas, carbon dioxide. This is oxygen, which is a gas, and propane itself is also a gas. So propane is a gas that is usually found alongside butane in our cooking gases. So now when propane undergo combustion, it will produce CO2 and steam. So now this equation is not actually balanced because if you check here, we have three carbon atoms, but here we have only one carbon atom. Here we have 8 hydrogen. Coming here we have 2 hydrogen, so it's not balanced. So how do we go ahead to balance this? So using the algebraic method, the best thing we should do here is to label the moles here. We should label them with alphabet. Let's say we call this one A. This is A. This is B. If I use C here, it will be confusing, so I can use X, and here is Y. So now, what are we going to do? So we are going to bring out each of the elements that are involved in this chemical reaction. We have carbon, we have hydrogen, but we have oxygen. These are the three elements. So we are going to split it into three. So we have carbon first. After carbon, we have hydrogen. After hydrogen, we have oxygen. So going with carbon, so if you check here, we have three carbon atoms. The three here we use it to times the A, the number of moles there. 3 times A is 3A. Then in this reactant side, we don't have any carbon again, so we'll go to the product side. So going to the product side, we have only one carbon atom here. So when we times this, we are going to have it as what? X. So we are done for carbon. Let's go to hydrogen. So hydrogen, we have 8 here. 8 times A will give us 8A, which is equal to, let's come here, we have hydrogen, we have 2 atoms here times Y, that's 2Y. Then oxygen, which is the last there, 2 times B is 2B, is now equal to, oxygen is here, which is 2 times X is 2X. But you notice that we still have oxygen here, so we have one atom of oxygen here. So 1 times Y is going to give us Y, so plus Y. So these are the three equations we need in order for us to resolve this. So after getting these three equations, the next we are going to do, we are going to assume one of these unknown to be 1. Either is A, B, X, or Y. So we can assume X is equal to 1. So if I assume X equal to 1, this my first equation will become 3A is equal to X is what? 1. So I'm not using X again, I'm using 1 because I've assumed X to be 1. So I can find A from here by dividing both sides by 3. So divide both sides by 3. So 3 comes into it. A will give us 1 over 3. Therefore means A equals to 1 over 3. So we're done with A. We've gotten A, we've gotten X. Then let's move over to the next equation. So if you check the second equation, you notice we have A. 8A equals to 2Y. Since we already know the value of A, That means we can use the second equation to get y by substituting the value of a to be 1 over 3. So by doing that, we are going to have 8 bracket a is what? 1 over 3. So we have 1 over 3 is equal to 2y. So 8 times 1 over 3, 8 times 1 will give us 8 over 3 is equal to 2y. So we can cross multiply here. 2y times 3 is going to give us 6y is equal to 8. So we can divide this side by 6 by 6. Then y is going to give us, we can reduce this fraction. 2 here is 4, 2 here is 3. We are going to have 4 over 3. So this is our y value. So we've gotten y as 4 over 3. Then I think the last thing there is we've gotten x, we've gotten a, we've gotten y. I think the last thing there is b. So how do we get b? We can get b using the third equation. So the third equation is saying 2b is equal to 2x. Or what is x? X is 1. Okay, 1. Then plus, what is y? Y is 4 over 3. So we have 4 over 3. So this is going to give us 2b is equal to 2 times 1 is 2 plus 4 over 3. So now we can actually look for the LCM between the denominators here. And the only denominator we can see here is 3. We know the denominator of 2 is 1. The denominator of 2b is also 1, like a fraction. So the LCM between 1, 1 and 3 is 3. So we are going to multiply all through by the LCM. We multiply it 3 times here by the LCM, which is 3. So the first one is 2b, we multiply by 3, equal to, the next one is 2, we multiply by 3. The next one is 4 over 3, we also multiply by 3. So by doing this, 2b times 3 is going to give us 6b, is equal to 2 times 3 is going to give us 6. Then 3 we cancel 3 here, we are going to have plus 4. Therefore, 6b is now going to give us 6 plus 4, which is 10. So we can look for b by dividing both sides by 6. So b is now going to give us 5 over 3. So if we divide here, 2 into 6 is 3, 2 into 10 is 5, 5 over 3. So we are going to impute the values that we've gotten into the equation initially. So we have a, and a is 1 over 3. We are going to have 1 over 3, then C3H8 plus b is what? B, from our calculation, b was 5 over 3. We have 5 over 3 O2 to give us, what is x? X was 1, so we can put 1 CO2 plus, what is y? Y was 4 over 3. That's 4 over 3 is 2. So from here, what we are going to do is to remove the fractions. So now LCM is 3, we multiply all through by 3. So if we multiply all through by 3, we are going to have 1 over 3 times 3 C3H8 plus 5 over 3 times 3 O2 to give us 1 times 3 CO2 plus 4 over 3 times 3 is 2. So from here, can cancel 3 can cancel 3, 3 can cancel 3, then 3 can cancel 3. Here we now have 1 times C3H8 plus 5 times O2 is 5 O2 to give us 1 times 3 is 3 CO2 plus 4 times 1 is 4 H2O. So this is our balanced chemical equation. Now let's check if it's balanced. Here we have 3 carbon atoms, here we have 3 carbon atoms, here we have 8 hydrogen, here we have 8 hydrogen, 4 times 2, 8. Oxygen here we have 10 here in the reactant side. If you check here, we have 6 plus 4, which is 10. So it is balanced. So this is the way of using algebraic method to balance the chemical equation. In the next video, we shall see another way other than using algebraic method, which is a special method for only combustion reaction of hydrocarbons. So please don't forget to like, share the video.